have my vision. I'm dehydrated. My DNA is all wackadoo.
It's just not a good scenario. I don't recommend it as next summer's vacation plan.
Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome back from summer break.
Boo.
You don't want to be
We're in
here?
School again? Gross.
Cheryl, you know that you picked to be here, right?
Dang it. This was an elected course.
Yeah, you're not required to be here. You can leave anytime you want.
Oh my goodness. I did not like going back to school when I was a kid though. Oh, summer break was so much better. But
yeah, I've got
it was
news
nice
for you.
Yeah.
Teachers don't like going back either.
So nobody likes it. Got it. That checks out. I could see that. Yeah. It was nice for us to take a break. Worked ahead a little bit. That's a good thing in school, right? We worked ahead.
Yep.
Preparedness, planning.
Yeah. All those things. Yeah. But are you ready now to dive in with a whole new unit?
Okay, because of what this unit is, I'm pretty pumped, actually.
Yeah?
Yes. Yeah, definitely.
I mean, we've been talking about this for a while.
Yes. We've been talking about doing something about space, something or other about space. We've touched on space little bits, we've done a couple lessons on it. But what really kind of sparked this was when we talked about the vacuum of space, and I asked you what would kill you first in space between two different options. And you said, do you remember what you said?
I probably said something like, lots of things can kill you in space.
Yes. Yes. So we're going to talk about some of the things in our solar system that can kill us, Ryan.
Yes. We are going to call this new unit our deadly solar system.
So cute. We'll do like a little paper mache. Like, here's what I'm picturing is like the little, the ones that the kids make where they make the different planets and it's like hanging or something, but with like
a mobile or something.
Yeah,
with teeth on them.
And claws.
Yeah. Perfect. Well, this is going to be lesson 77. And for this one, we're going to start in the center of our solar system with the sun. What question do you have about the sun, Cheryl?
Okay, this is a question I've wondered for a long time, actually. How close could I get to the sun before burning to a crisp?
Okay, great question. Were you thinking maybe next summer going to the sun, and so you're trying to gauge how close you can get?
Yes, exactly. Yeah.
Well, let's move into the pre-assessment and find out some things that you already know about the sun. Let's start with, why do you think the sun might burn you to a crisp? What makes you think that in the first place?
Well, okay, so like I was thinking through even the difference of where you are on our planet, which I know like compared to the distance between us and the sun, the distance you can travel on our planet is not very big.
Right.
So even on our planet, you can go places that you could freeze to death. Or, I mean, if you just like laid out on a really, really hot day in the desert, you would die from that, right? Yeah, you could die or freeze to death because of the varying temperatures just on our planet. And so I would imagine if you got much closer to the sun than us, that you would just burn alive very, very quickly. But then also you were telling me that if we were out in space without like a suit on, like an astronaut,
which I don't recommend, by the way.
Yeah. That you would freeze to death, which means it's not just about how far you are from the sun. It's also about being like within an atmosphere, it sounds like. Because we were like the same distance from the sun, but in space, we would freeze to death, right? So it's not just like equal distances means equal temperatures. Atmosphere has to do something too. So like I think about it in a Doctor Who episode, I think they saw the sun very close. Probably in Futurama this has happened. Maybe other like spacey things are like flying up to the sun somehow. So I'm thinking like if we just like were in space and going towards the sun, is that a different distance than if I was like teleported to the closest planet to the sun? Like how close can I get to the sun?
How close can you get to the sun before what?
I burn to a crisp.
Oh, and before you burn to a crisp.
Yes.
Okay. All right. How close do you think you could get? And obviously, you don't have to give me a number, but do you think, well, let's take one step back here. Do you know the planets in the solar system?
Oh gosh. I know I could probably list them all. I don't know if I could list them in order.
Do you know which one's closest to the sun?
Is it Mercury?
Yes.
Okay.
Do you know which one's next?
Venus.
Okay. And then?
The third rock from the sun.
Which is?
Earth.
Okay, great. We're just going to do those three for right
Yep.
now.
Okay.
Do you think any of those planetary distances, if you were like between Earth and Venus, or at Venus, or between Venus and Mercury, or at Mercury, or between like the sun and Mercury, like where do you think that distance might be that you would be burnt to a crisp?
So that's where I wonder, like, if I were like on Venus, would I be in its atmosphere? And so I'd be experiencing the heat from the sun in the same way I experience the heat from the sun on Earth. And then I think I would die if I was on Venus from the sun.
Okay.
But then if I shot straight up in the air in a rocket and I was in space, same distance as Venus, would I still freeze to death there? Even though I'm closer to the sun? I think you could get a lot closer to the sun if you weren't in an atmosphere. That doesn't make any sense to me, but I think that's true.
Okay, so let's get rid of the atmosphere component. How close do you think you would get?
Mercury distance.
Mercury, so about the distance of Mercury is what you're thinking.
That's my guess.
And why did you guess that?
Well, if I would freeze to death in space at Earth distance, then I'm guessing you'd have to get a lot closer before you wouldn't freeze to death. But I don't know.
Okay.
I don't know. This is tricky.
It is tricky. The next question is, assuming whatever that distance was, that you are close enough to be burnt to a crisp, what would actually be burning you to the crisp?
Well, is it sunlight? Because we talked about sunburns and that my skin can get burnt. Or is it dehydration? Like, did I get dehydrated? No. It would be burning like an oven burns.
Which is how?
The air's just too hot because of... So this would be from light. The sun would make the air around it, or there's not even air around it if it's in space, but whatever, it'd make the space around it too hot. So would I look charred? I think I would. You can char things. It'd burn like something burns in an oven. Just char up and then become dust.
It would look like something burnt in an oven, but not caused by the same thing? Or do you think it's caused by the same thing?
I think it's similar. I think it'd be similar to how an oven works as far as like how I would burn.
Okay.
This is complicated.
Surprise! Welcome back from summer break. This one, Cheryl, is quite interesting, and I think it may go in a different direction than either you or I originally thought that maybe it would go. To start with, I would like to show you a picture, if I may.
Okay, great.
Yes.
This is where I remind our listeners that if you are listening to our podcast, you can hop on over to our YouTube and check out Ryan's amazing screen shares for yourself.
What I'm showing you is a photograph that I took of the sun.
Really?
Yes, this was in 2017. Now, technically, it's through a telescope, but it's with my phone looking through a telescope. This is a photograph of the sun during a total solar eclipse. Maybe someday we'll talk about what those are. The short version, the moon is blocking the sun so that you can look at the rest of it. And what do you see around the edge of where the sun should be?
Sunlight.
Sunlight. Yes.
Mm-hmm.
How might you describe it? Does it look like the way sunlight normally looks?
I mean, yes and no. Like I see like lines coming out from it. Like it's not like it's like an equal, because it's called a halo, right? Is it a halo? It's like not an equal amount. There's like, are those rays? Are those sun rays? But then also what's striking about this is the fact that beyond the light is just blackness. So is that because it's through your telescope or because
it's because the moon, you're looking at the backside of the moon.
Well, I understand that. No, I mean beyond the sunlight on the outside.
Oh, on the outside of it, the rest of it. It's because it's dark. None of that light's getting to us. And again, we can talk more about that later. But that kind of fuzzy light that you see on the outside, that, it has lines that we don't normally see. That is called the corona of the sun.
Oh.
Have you heard that before?
No.
But you've heard the word corona before.
Like the beer or like the city?
Or like the virus, all of the above.
Oh,
it
yeah.
all means the same thing. Yeah, I'll bet you did. The corona means crown.
Oh, that's right. Yeah.
Yeah. And so that's the corona of the sun. You talked about atmosphere. You were talking about, I think, the Earth's atmosphere and trying to get out of the Earth's atmosphere. But the sun actually has an atmosphere as well. And we call it the corona.
Oh, okay. That's
and it is quite large. This photograph doesn't show the full extent of the corona because my camera was limited, but it is very, very big. And the corona is actually what would burn you to a crisp, to use your words, as you got close to the sun. And believe it or not, the corona of the sun is hotter than the surface of the sun.
Oh, that's so interesting.
It is. And we don't know why.
What?
We don't. It doesn't make sense. It shouldn't be, because as you're getting farther away from the source of heat, it should be getting colder, and it doesn't. The corona is hotter than the surface of the sun, which is interesting, which actually means we, not me, but we as in like humanity, have a probe called, NASA has a probe called the Parker Solar Probe that is currently in orbit around the sun and getting very close to the sun in an effort to figure out an answer to that question.
That's so cool. You know, what's really funny is I have a guess, but I feel like if scientists don't know, then I doubt like my guess is like, oh my gosh, we cracked it.
Well, what's your guess though?
Well, I think it might be similar because if the sun has an atmosphere, then like I wonder if it's similar to how if you're in a car on a hot day with the windows closed, it's hotter than it is outside because it's like making an oven in there. So I wonder if the sun is like making its own oven in its atmosphere where it's just like getting worse and worse because it's all like insulated in there.
That is a great hypothesis. That's not really all that's going on. There's a couple of problems. One, unlike the Earth's atmosphere or like the glass of the window of the car, the sun's corona is constantly streaming away from the surface of the sun. It's actually
Okay.
actively moving away. It's stuff from the surface that gets blown out into space. That's called the solar wind, and lots of things that, of course, is more complicated than I'm making it out to be, but it's very cool. The other thing is, if you think about your car, especially let's say you have leather seats, while the car is hotter on the inside than the outside air temperature, if you put your hand on the leather, that is even hotter. And that would be equivalent to the surface of the sun.
That's so interesting.
It is. It is. There's a few hypotheses that scientists have, but we don't know for sure. The cool thing about the Parker Solar Probe is how close it's getting to the sun, and it's going into the corona and taking measurements and doing all sorts of really cool things, which is very exciting.
And not burning to a crisp?
And not burning to a crisp for a whole host of reasons, not the least of which is it has a heat shield constantly facing towards the sun. That's kind of an important part.
Okay, that's good. Okay.
Yeah. Okay. Getting back to your question, though, is how close could you get to the sun without being burnt to a crisp? And it's actually closer than you might think.
Okay.
If we were to make the distance between the Earth and the surface of the sun, which is 93 million miles on average, just so you know, if we were to make that a football field, so like 100 yards.
Okay.
Right? Mercury would be about 40 yards from the sun.
Okay.
Is that making sense?
Yes. Yeah.
Okay. You could get about 5 yards away from the sun before you would be burnt to a crisp.
Away from the sun?
Away from the surface of the sun. Like the Earth is 100 yards away from the surface of the sun.
And I could get
Mercury would be 40.
Uh-huh.
You as a human, if you're in a spacesuit,
wow, I could get that close.
You could.
I mean,
and then
it's
you
still
would
millions
die
of miles.
terribly. Yes, it is. It is still about between 3 and 4 million miles from the surface of the sun.
But how would I die terribly?
You would, so you would heat up, and then kind of that greenhouse effect, like you were talking about in the car, the same thing would happen, but in your suit, where it would heat up, and then it would be like a sauna, and then all of the moisture would evaporate out of your body, and you would desiccate, which is like dry out, and you would like dehydrate and pass out from heat exhaustion.
And then when would the crisp part come in? Like,
well, you would just continue to bake. You would continue to bake. And then exactly how crispy you would be, I guess I don't know. You know,
like, and then at what point would like the spacesuit just like, is there a point where everything would just burst into flames? Like it's just that hot?
Yes.
Or is that not how it would ever work?
It wouldn't burst into flames because in order to have flames, you need oxygen.
Okay. Yep.
So it wouldn't really burst into flames, but yes, things would start vaporizing. A couple of things would happen. The actual suit, the material would start breaking down. If you've ever seen things that have been in a lot of sun and they kind of break down and crack, they kind of come apart, become weaker because all that energy starts breaking things down on a molecular level. So that would happen. And eventually, if it got hot enough, it would start vaporizing, like just turning things from a solid into a gas.
That's so cool.
I mean, it would be very hot, actually.
So I wouldn't burn to a crisp foam, which is vaporize eventually.
Yeah, I mean, you wouldn't be burning in that you wouldn't be on fire, but you would be crispy because all of the liquid, all the water in you would leave. And so that would make you crispy, I think.
I'm picturing more like a dead, dry bug or like a snake skin or like, you know what I mean? Just like it's still there, but it's just all dryness.
Yeah.
Interesting. Wow. Yeah. So I don't think I want to do that.
No,
then.
I wouldn't vote for that. Mm-mm.
Okay.
I would vote for a big no on that one. But if you wanted to, now you know how close you could get.
Just a couple million miles away.
Just a few million miles.
Oh my goodness. Wow. I would also be blinded though.
Well, there's a whole lot of other things that would definitely happen because one of the things we didn't talk about is what else is coming from the sun. The atmosphere, while yes, it can have the greenhouse effect, it also protects us from some of the light that comes from the sun. The higher energy ultraviolet rays, there's gamma rays, there's really, really harmful light that doesn't come to the surface of the earth because our atmosphere protects us from it. Once you get outside our atmosphere, you're not protected from that anymore. So you've got all that stuff that's also like breaking down DNA and doing all sorts of really terrible things to you. So
there's all sorts of things happening.
All sorts of things.
I don't have my vision. I'm dehydrated. My DNA is all wackadoo.
Yeah, I mean, it doesn't happen immediately, obviously. It takes time for all of that to happen, but it's just not a good scenario. I don't recommend it as next summer's vacation plan.
Oh, okay, I'll go ahead and change it just to like Death Valley or something like that.
There you go. So much better.
Yeah.
And now, Cheryl, it is time for your first quiz of the new school year.
Oh, that's even worse than the first day of school. Is then like you have to like retain the information after learning it?
Only if you want to pass.
I do want to pass on this course that I'm auditing, I guess.
All right, first question. What do we call the sun's atmosphere?
The corona.
The corona. Very good. How far away is the sun from the earth?
93 million miles.
Very good. I wasn't sure if you would have picked up on that. Nice job. Mm-hmm. How close could you get in a spacesuit before being burnt to a crisp?
5 yards, or a few million miles. I think you said like it was a few. It was like less than 10.
Yeah, 3 or 4, somewhere around there. 3 or 4. Next question. What would cause you to actually burn to a crisp?
The heat. Dehydration would be the actual cause of death, right?
Yeah.
Yeah.
And why would you dehydrate?
Because in my cute little spacesuit, it would be like the oven greenhouse effect, like in a car where the air would just heat up a lot and then suck all the water out of me, or like something about condensation.
Yeah.
And then that would all go away and I would not have any liquid inside of my body anymore. Which
would be a bummer for you. Side note, you mentioned during the pre-assessment that you thought that you would be heated up very similar to the way an oven works. And I would say, no, not really. And you sort of even got at it a little bit on your own and then came back to it, because an oven uses heated air and there isn't air in space. It's radiative heating. So it's from just the light. There are some things where you can get light to actually heat, and there's a few fancy pants devices that'll do that, but a regular oven doesn't really do that. It heats up the air and then the air heats up the food. So there's no air to heat you up, just as a side note there.
So then it's hard to really have any comparison to something on Earth.
Yeah.
To what that's like, because we have air all over the place.
Exactly.
Around here.
We do.
Interesting.
Yeah.
Okay.
Yeah. Bonus question. What are some of the other ways you could die if you were to get close to the sun?
My DNA could break down from another damaging kind of light from the sun.
Gamma
like
rays.
A gamma ray. I mean, I still think going blind, while that wouldn't kill me in and of itself, would not be a fun experience necessarily.
Yep.
And then, shoot, I don't remember the other ones you listed now.
Those are the big ones. Those are the big ones. I talked about how the suit itself would start to break down too.
Oh, that's right. Yes.
Which then I suppose if it broke down enough, then you could also sort of both freeze and dry out at the same time.
Would I feel cold and hot?
You'd be dead already, so you wouldn't feel anything. I think that's where we're going to end our unit or our lesson today.
I'm so excited for this unit. It's going to be great.
All right. Well, why don't you pack up your stuff and get ready for my closing remarks?
You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.